Okay, in today's lesson, we're going to do what's called domain and range. And in the past two lessons, you guys have looked at average rate of change and just inputs and outputs and evaluating functions. So that's all going to come in handy during this lesson here. So let's first start by defining what domain and range actually is. They sound like scary words, but they're actually just vocab words to talk about all possible inputs of a function, or the x values. It's usually the x values on your horizontal axis. And then if you can guess, range is all the possible outputs of a function. And those are the y values. So in this video, I'm going to go through, how to identify domain and range from a function, relatively simple functions, and then I'm going to make another video that kind of goes into depth about more complicated functions, word problems, etc. So this video is really just a basis of what you need to know. It should be fine to do the practice, but if you're looking for that extra deeper understanding of domain and range and more complicated examples, I'm going to provide a video on that. That's what we would have done and what you will kind of be expected to know in Algebra 2, but this is just going to be a basis of what that is. So it says consider the function y equals f of x. And remember, f of x is the same thing as y, so that's why we can set them equal. They both represent outputs. Evaluate the following. So I can also, the reason why they say let f of x equal y is I can actually just label this axes f of x. They're both output axes, so they're equal to each other. So if you remember kind of from our functions unit, we're going to look at what f of negative 3 is. So to do it on a graph, this represents my x. So I'm going to look for negative 3 on my x-axis. Negative 3 on my x-axis is 1, 2, 3, is right here. So I'm going to look for my graph there. So my graph, I can look up. My graph is at when y is 1. So actually the answer to that is just 1. And so then I can do it for other values. I look at where x is 1 for f of 1. Where x is 1, my function is all the way down here. So this is x is 1. So I'm going to look for my y value, which is where I go down, and it looks like my y value is negative 3. So at that place, my y value is negative 3. Now I want to see when x is 3. So when x is 3, I'm going to go over to my graph, 1, 2, 3. So that's here. When x is 3, I go up to my graph, and I look over. It's going to be 1, 2, 3, 4, 5. When y is 5, when x is 3. So if you remember, I can also write these as points. So I can write this as negative 3, 1, 1, negative 3, and 3, 5. So that's just another way to write points on the table. Okay, so next it says, can the function rule given by the graph give you a value for when x is 5? If so, what is it? If not, why? So I'm looking for specifically f of 5. When x is 5, oops. When x is 5, what is y? So I'm going to go over to my graph again. I'm going to go over here. 1, 2, 3, 4, 5. And if you look here, there are no values on this graph that are at when x is 5. So this does not exist because there's no value when x is 5. So that means that 5 is not in the domain of the function. There's no input values of 5 in this particular function. If this function maybe had arrows on it, we could indicate that it goes on forever, but we don't, so we can't indicate that, which means no. I can actually type this in. No, 5 is not in the domain of the function. I'm looking at domain is always x values. For the rest of your life, domain will always be the x values. So then it says give two other values of x that are not in the domain of the function. So where else on the x value there are no other graph? Well, I can also see that when x is 4, there's no line. This line does not go across when x is 4. So I know here I can write when x is 4. And then another place we could look, there's two other possible ones. One is right here when x is 6, or on this other side when x is negative 1, 2, 3, 4, 5, 6. So negative 6 or positive 6. So when x is 6 or x is negative 6. So these numbers are not in the domain. They're not in the input of this function we have on our graph. So then similarly, we can look at range. Circle the following y values that are in your range of the function. Show evidence on your graph. So y equals 0. Y equals 0 is right here. It's when my y value is 0. Whoops. So there, look at my function is all over there. So I'm looking at my y, my function is there. So yes, that is in the range. So we don't need to circle that one. Oh, we do need to circle it. So y is 0 is in our range. So now we're going to look at what y is 6. 1, 2, 3, 4, 5, 6. So when y is 6, is there any graph at that point? No, because if you look, and now it's getting hard to see with all my lines. That's our function. All the way at the top, there's no line there. So y equals 6 is not in my range. Y equals negative 1. Negative 1 is right here. That, in fact, there's a point there, there's a point there, there's a point there. So y equals negative 1 is in my range. And then I'm going to look at y equals 3. We'll do pink. Y is 3. 1, 2, 3. So yes, look at crosses right there. So y is 3 is also in our range. Let's look at negative 5 and 4. So negative 5 is going to be 1, 2, 3, 4, 5 down here. That is not in my range. And then 4, 1, 2, 3, 4 up here. Yep, it crosses right there too. So 4 is in my range, negative 5 is not. So those are all values that are in my range. So then we can also write domain and range as inequalities. So the first thing I want to do is I'm going to erase this. Whoops. Probably going to be better if I do it this way. There we go. Okay, so I want to look at what are all the numbers that are in my domain. So there's a couple ways we can do this. And I'm going to actually draw a rectangle here. And I'm going to draw another one here. And I want to see if I can fill those in. I don't think I can. But anyway, so if you look at those rectangles, I always, if I'm looking at domain, I like to look at the x-axis. So if you look at my x-axis, I'll highlight it in yellow. My domain is all of the values that are on my x-axis of the line, so, or the curve in this case. So if I look here, the farthest x value is going to be right at the bottom of that function right here. So then if I can move, I move this just to the very tip, and then I also move this one here. Now let's look at my values that are in between there. So my farthest one to the right is 1, 2, 3. So 3, and then negative 1, 2, 3, 4, 5, negative 5. So I know that my domain goes from negative 5 to 3. And I'm just going to leave that space there because I want to talk about what happens in between. So does it include 2? Yes, it includes 2. Does it include 1? Yes, 0, negative 1, negative 2. Includes all those numbers. But do you see how the line is connected? That means every single value, like 1.5, 2.5, 3.5, 3.9, or 2.99999 is all included in that domain. So that's why we can use interval notation, because I want to indicate that there's all the x values. So if you remember, we're going to write an interval notation like this. So x is greater than or equal to -5, and x is less than or equal to 3. And so how I decide if it's equal to or not is I go back up and I look if there's an open, so if there was a point that was open right here, that would mean it's not defined at that point and 3 would not be included. But since there's a solid point or a solid line, you can assume that it's equal to there. Okay, so that's domain. Range is going to be opposite. It's going to be looking at our y-axis. So let me just erase this here. I'm going to draw some rectangles again, but now I'm going to look at just my y-axis, which means I'm looking up and down. So my y-axis is up and down with this yellow part right there. So I want to look at that axis. Where is my function at the lowest? So if I look, the lowest would be right at the bottom of that curve right there. And my highest is going to be right at the top of that line right here. That's the highest point on the curve, and this is the lowest point on the curve. So when I identify the highest point and the lowest point, those are the values that are going to be, everything else is in between. So this is going to be -1, -2, -3, -4, and this one's going to be 1, 2, 3, 4, 5. So down here I would write my y values are going to be less than or equal to 5 and greater than or equal to -4. I want to make sure that's right there. -1, -2, yep. So that is the range of my y. So there's a million different ways you can write this, which is kind of annoying. But another way you might see this is in bracket notation, it's called, or parenthesis notation. So anytime you have equal to, you can write it using brackets. So my function, my domain is from -5 to +3. That indicates equal to, the brackets do. So then I could also write this as -4 to 5 with hard brackets around it. If you didn't have equal to, if you just had less than, that would be parentheses. So -4 to 5 if those weren't equal to. So it looks kind of like a coordinate point, but you could see it written either of these ways. This is both interval notation, which means all of the values between those numbers are covered, even decimal, irrational, rational numbers between those things. So that is pretty much domain and range. The only thing I want to talk about in the last couple minutes is what if I have a function that I'm not looking at the whole thing, I'm just looking at certain values of the function. So in this, it says, given the function f of x equals x/2 minus 3, and the domain shown below, fill in the range. So basically, they're taking this function, and they want to look at what are only the range values for this number, and this number. So again, domain stands for x, and range stands for y, or it includes the y value. So I'm looking at when my x values are -4, 6, and 10. So you can either do this on a graphing calculator or on Desmos. And I'm going to type in x/2 minus 3. And I'm going to go to the table for this. So I'm going to go to the table function. And I'm going to look for when x is -4. So I can type in -4 and it'll tell me when x is -4, my y is -5. So I can really just write -5 here and draw an arrow that says when x is -4, y is -5. I can do the same thing for 6. If I look and I type in 6, it'll give me 0. So I can say when x is 6, y is 0. And then when I look at 10, it'll say 2. So when x is 10, y is 2. So if you look, those are my domain and range for just specific numbers. So if you notice, I'm not looking at all the numbers in between -4 and 10. I'm only looking at 3 numbers for this whole function. So there's a thing called function or set notation, which means, and I'm going to do this fast so in 30 seconds, a curly bracket like that, and I'm going to list my numbers from smallest to largest. So -5, 0, and 2. And so that would be my range of these just specific numbers. So that's if you don't want to include all the numbers in between. It's just only certain numbers. So I'm sorry this was so long, but tune into the next video for more.